Hello students, welcome to aimstoday online classes. This is chemistry session. Here we are discussing about matter chapter. In this session, we are going to see about chemical classification of matter. That is the classification of matter based upon the composition of the substances. In the earlier sessions, we have seen about the classification of matter based upon the physical properties. That is nothing but based upon the arrangement of molecules. The classification of matter into five states like solids, liquids, gases, plasma, and BEC. That we have seen how that was classified into different states. Now, the same matter can be classified based upon chemical composition also. So the chemical classification of matter now we are going to see. When we talk about matter, usually we talk about a substance which possesses distinct properties and has definite composition. So matter nothing but just we say simply as substances. They'll be having certain properties and they have a definite proportion composition. For example, if I say sugar, table salt, or nothing but sodium chloride, water, gasoline, petrol, etc. These all are different chemical substances. Nothing but they come under matter only. All these substances do not have same composition, isn't it? They are having different composition. They do not have same kind of composition. Different substances have different kinds of substance compositions in them, but it can be identified by their unique properties. So as they are made up of different components, they will be getting unique properties to them. Because of those unique properties, we can identify them. For example, if you say sugar, it is having some special property like it is sweet, it is sweeter, dissolves into water. So because it is having a peculiar composition, based on the composition, it gets these properties. In this way, different substances which are made up of different compositions, they get different properties and different characteristics to them. So based upon that, we can classify the matter. So matter is classified into two broad categories, namely pure substances and mixtures. So based upon the chemical composition, matter can be broadly classified into two categories. They are pure substances and impure substances. These impure substances are also called as mixtures. Pure substances are further classified or further divided into two categories. They are elements and compounds. Similarly, even these impure substances or mixtures are also classified into two categories. They are homogeneous mixtures and heterogeneous mixtures. So this is a classification of matter based upon chemical composition, which we say as chemical classification of matter into two categories. They are pure and impure substances. Pure substances again categorized into two. They are elements and compounds. In the same way, impure substances are also classified into two categories. They are homogeneous mixtures and heterogeneous mixtures. So you can see here in chart way diagrammatically shown how matter is classified into pure substances and impure substances, which are also called mixtures. So these pure substances again classified into elements and compounds. So here the substances which are made up of only one kind of atoms, the substances are pure substances formed by the combination of two or more elements is called compound, and the impure substances classification into homogeneous mixtures and heterogeneous mixtures. Okay, now let us see about pure substances first. A pure chemical substance is any matter that has a fixed chemical composition and characteristic properties. So if any substance, if it is made up of only one kind of particles, only one kind of particles is called pure substance. It will be having fixed properties to it. For example, oxygen is a pure chemical substance that is a colorless and odorless, which is used in the respiration. So oxygen is a pure substance because it is made up of only one kind of particles. They are oxygen molecules. The substance containing particles of only one kind is called pure substance. So to say simply, the substance which is containing only one kind of particles in it is called as pure substance. Okay, those might be either atoms or molecules. If they are of only one kind, then it is said to be a pure substance. For example, iron, silver, oxygen, these all are pure substances which are made up of only one kind of atoms. And even carbon dioxide, sodium chloride, these are also examples for pure substances. So these are made up of more than one kind of atoms. So these all are pure substances only. Now we can say these pure substances are further divided into elements and compounds. See here two categories are there in the pure substances, elements and compounds. So a pure substance can be either an element or a compound. So first of all the elements are building blocks of the nature. So elements or the building blocks. So any matter may be made up of only one kind of elements, or that might be in combination of two or more kinds of elements. Anyhow, every matter in this universe is made up of these elements only. They are composed of one or more than one kinds of elements. So we can say the building blocks of this nature are elements, isn't it? Yes. So now we can say pure substances are of two kinds, either elements or compounds. First, let us see about elements here. An element is a substance that is either discovered in the nature or synthesized in the laboratory by the scientists in pure form that cannot be separated into simpler substances by chemical methods. That is called element. Element is a pure substance which is containing only one kind of atoms in it. So these some of the elements are naturally identified from the nature, and some are prepared in the laboratory. So some are discovered from the nature and some are prepared in the laboratory, synthesized in the laboratory. So these are which are containing same kind of atoms in them are called elements. They cannot be separated into simpler substances by any chemical methods. They are called elements. In order to call it as an element, its properties must be unique. No two elements are alike. So each and every element is having its peculiar properties for it. Its unique properties. So no two elements are having all the properties same. Elements carry names and symbols. Yes, we know till now all our scientists they have discovered around 118 elements so far. Each and every element is given a particular name and its own symbol. So these symbols were given, the suggestions for giving symbols was given by the scientist, as we know, Bergelius. He has given some rules for writing the symbol of an element. Suppose the first letter of its name is taken as a symbol for an element. If the first letter is already given as a symbol for some other element, then the second prominent letter also is taken into its symbol along with first letter. For example, now let us say the first element of among all the elements is hydrogen. What is the first letter in the name of hydrogen? H. So H is a symbol for hydrogen and it is written in the capital letter. And let us take one more element, helium. For this helium is also the first letter is H only. But this H is already given as a symbol for hydrogen element. That is why for helium, along with the first letter H, second prominent letter E also taken into its symbol. Now it becomes He. The symbol for helium is He. Symbol of hydrogen is H. In this way, whatever the elements they were discovered at the time, he has given symbols for those elements. And For the remaining elements also, he given some suggestions and instructions how to give symbols. So they are the first letter of every element is taken as its symbol and it is written in the capital letter. If this first letter is already given as symbol for some other element, then second prominent letter also taken into its symbol and the first letter is written in capital and second letter is written smaller. Now let us see here some examples. If we say hydrogen, hydrogen symbol is H. If we say carbon, symbol of carbon is C. If we say nitrogen, symbol of nitrogen is N. Oxygen, O. Sulfur, S. In this way, each and every element is having its own name as well as its symbol. No two elements are having same name as well as same symbol. All they are having unique symbol and names. Classification of these elements. There are around 118 elements so far our scientists they have discovered. Of course, they may discover further some more. But till now, they have identified and discovered 118 elements. Out of these 118 elements, 92 elements are naturally occurring elements and the remaining are artificially synthesized by the scientists. Okay, 92 elements are naturally occurring elements and remaining are synthetic elements or artificially synthesized elements, which we call simply as man-made elements also. So on the basis of their general characteristics, these 118 elements are broadly divided into four groups. They are metals, non-metals, metalloids, and noble gases. So based upon the generalized characteristics, these elements are classified into four groups: metals, non-metals, metalloids, and noble gases. Now let us see one by one these. First among them, metals. Metallic elements in general exhibit the following characteristics. So the elements which are exhibiting these following characters will come under metals. Let us hear those. First one, all metals are solids at room temperature. Generally, almost all the metals are solids, hard solids at room temperature. Metals are good conductors of heat and electricity. That means they can pass electricity and heat through them. Almost all the metals are good conductors of heat and electricity. Metals are malleable, ductile, sonorous, and have luster. What are these properties? Let us see once here. Malleable. Metals are malleable. That means metals can be beaten into very thin sheets. That property of metals by which they can be beaten into sheets is called malleability. And metals are ductile. That means metals can be drawn into very thin wires. The property of metals by which they can be drawn into thin wires is called ductility or ductile property. So metals are ductile because they can be drawn into very thin wires. One more property, sonorous, means metals they produce sound on hitting them with an object. Very fine example for this temple bells. Temple bells are made up of certain metals. So when you hit them with an object, they produce a sound. Not only temple bells, even school bells, these also will come under sonorous property. So metals produce a sound on hitting with an object. This property is called sonority or sonorous property. So metals are sonorous. And they have luster, means they are shining. They have shining surfaces. When they are pure, they will be shining on the surface. That shining property is called lustrous property. So we can say metals are lustrous. Metals are malleable, ductile, sonorous, and lustrous. Metals are strong. They have high tensile strength. Tensile strength means bearing much strain. So even though if you take a metal thin wire that can bear much strain, we cannot break them into easily. They will be very strong. That is called tensile strength. For example, if you see the spokes of our cycle wheel, they will be very thin, but they can bear our much weight also. Even 100 kgs of weight also they can bear. Even they are very thin. So the bearing capacity is called tensile strength. So metals are having high tensile strength. Most of the metals are hard. Yes, we told at the starting itself, metals are hard solids. We cannot compress them. Metals have high densities. Yes, they will be heavy. Almost all metals are heavier. They have much density. So these are the properties of generalized properties of metals. The elements which are possessing these properties will come under metals. Even though they are generalized properties of metals, there are some exceptions. Let us see those. What are those? Mercury is a liquid metal at normal room temperature. We are telling almost all the metals are hard solids at room temperature. Almost all the metals are hard solids, but there is an exception. One it is mercury. Mercury is a liquid metal. At normal temperature, mercury will be in the liquid form. It is the only metal which exists in the liquid state at around normal temperature or room temperature. Room temperature is nothing but around 25 degrees Celsius temperature is considered as room temperature. At this temperature, mercury is the only metal which exists in the liquid state. But if we increase the temperature little, around to 30 degrees and above, one more metal will come into liquid state, that is gallium. So these are the exceptions. Except these remaining all are metals solids. Okay. One more exception, zinc. We are telling almost all the metals are malleable and ductile. But zinc is a metal which is a non-malleable, non-ductile. It is a brittle metal. It cannot be drawn into wires and it cannot be drawn into beaten into thin sheets. So it is non-malleable, non-ductile metal. Whereas almost remaining all the metals are malleable and ductile. One more exception, some metals like sodium, potassium, rubidium, cesium, we say first group metals, which we are going to learn in the higher classes. So these metals are very soft. Even we can cut them with a knife also. That much soft these metals. So we can say these metals are not hard, which we say generalized statement, metals are hard solids. But these are exceptions. So metals like sodium, potassium, rubidium are soft metals. They are not hard. They cannot be drawn into thin wires. They cannot be beaten into thin shades. They can be cut with a knife simply, just like a soap. Okay, these come under exceptions of metals. So from these are deviated from the generalized properties of metals. Okay, now let us see about non-metal. Examples of some metals are shown here. See, iron, aluminium, copper. These all are come under examples of metals. And some more mixtures of metals are also shown here, which we call as alloys. Brass, bronze, steel. So these all are the alloys, nothing but mixtures of two or more metals. Anyhow, these all are the made up of metals only. Next, let us see about non-metals. Non-metals in general exhibit the following characteristic properties. So the elements which exhibit these following characters will come under non-metals. See what are those? Non-metals are soft solids or gases. What did we say in case of metals? They are hard solids. But non-metals will come under soft solids or gaseous elements. Non-metals have dull surface. That means they do not shine. They are non-lustrous, we can say. Whereas metals are lustrous. They shine. Whereas non-metals, they do not shine. So we can call them as non-lustrous material elements. One more. Non-metals are brittle in nature. That means they break into pieces on beating with a hammer. So we said these non-metals are soft solids and even these are brittle. Brittle means The hard solid which breaks up into small pieces easily. Those substances are called brittle solids. Okay. Non-metals are bad conductors of heat and electricity. These non-metals, they cannot transfer heat or electricity through them. So they are called bad conductors or poor conductors of heat and electricity. Non-metals are non-ductile, non-malleable, non-sonorous. So non-metals cannot be drawn into thin wires, non-metals cannot be beaten into thin sheets, and even non-metals, they cannot produce sound on hitting with an object. That is why they are called non-ductile, non-malleable, non-sonorous. So the elements whichever exhibit these properties will come under non-metals. So these are the generalized properties of non-metals. But from these also there are some exceptions. Let us see those. First one, graphite. Graphite is a form of carbon which has luster and it is a good conductor of heat and electricity. Even this graphite is best used in electrical reactions as electrodes. Even in the batteries also this graphite is used as electrode, because even though this graphite non-metal, it is made up of non-metal, it is a good conductor of heat and electricity. That is one exception. Actually, graphite is one of the forms of carbon which is a non-metal. Even though graphite is made up of non-metal, it is a good conductor of heat and electricity, and it is having a shining also. Graphite has much shining. It will be glittering. So we can say this is a lustrous element. One more lustrous non-metal element is diamond. Diamond is also one of the forms of carbon. Even though it is a non-metal, diamond shines. It has a luster. So this also will come under exception here. So okay, let us see one more exception. Bromine. Actually, we are telling all the non-metals are soft solids or gaseous elements. So almost all the non-metals are either soft solids or gases. But only one element, bromine, is in the liquid form. Bromine is a liquid non-metal. Okay, it is a brownish, reddish brown colored liquid actually. Okay, these are the exceptions from the non-metallic general properties. Okay, next let us see examples for the non-metals. See here some examples. Sulfur, red phosphorus, carbon. These come under non-metallic elements. See, they cannot be beaten into sheets. If you see sulfur, it exists in the solid form. But when you make this a piece of solid to fall down, it breaks up easily into small pieces. That nature is called brittle nature. That we said non-metallic solids are brittle, means easily breaks into small pieces. Okay, these are examples for non-metals. Now let us say third category of elements, that is metalloids. Metalloids exhibit the properties that lie in between that of metals and non-metals. So some elements, they exhibit the properties which are in common to the metals and non-metals. Such elements which are showing the properties of both metals and non-metals are called as metalloids. What are those? Metalloids. Metalloids exhibit the properties which are in common to metals and non-metals. So, see some metalloids are shown here: boron, germanium, silicon, strontium, polonium, tellurium. These all are metalloids. So, these will show some properties of metals and some properties of non-metals. That is why they are called metalloids. The fourth category of elements is inert gases. The gaseous elements which do not combine with other elements and even themselves also, and exist as individual atoms, are called as inert gases. So the out of these 118 elements, around 7 elements are there which do not combine at all, which do not participate in the chemical reactions at all, and they don't combine with other elements, and even they won't combine themselves also. Mostly these will be existing in the individual atomic forms only. And even all of these will be in the gaseous state. That is why they are called inert gases. These inert gases are also called as noble gases, erogens, because all they exist in the gaseous form, or rare gases because they exist in the very less quantity in the atmosphere. That is why they are called rare gases. And even they are called zero group elements also because in the periodic table they are kept in the zero group, which we are going to learn in the further classes. So they are called even zero group elements also. They are the different names for the noble gases. Okay, see here examples for the noble gas are shown: helium, neon, argon, krypton, xenon, radon. These all will come under noble gases or ideal gases. Inert gases also they are called. Now, did you observe these all are shown in the electrical bulb forms? Because that is a major use of these gases. These noble gases are mostly used in advertisement to glow bulbs. That means whenever you see in the streets at the night time, on the shops, markets, we see names are written with some bulbs which are bent into the different texts. Have you seen them? So those texts or those tubes are filled with these noble gases. When electricity is passed through these noble gases, they ionize and produce different colors. That is why these noble gases are used in advertisement glow bulbs. One more important use of one of the noble gases, helium, is it is one of the lightest gases. Next to hydrogen, helium is the lightest gas. That is why this helium is also used in weather observatory balloons. The balloons filled with the helium will move up and up because it is the lightest gas. So along with the balloon, they send these weather observatory equipment into the atmosphere so that they can observe weather conditions. So helium is also used in weather observatory balloons. Instead of hydrogen, they use helium because hydrogen is one of the explosive gas. So it is not used. Next to that, helium is the latest gas, so it is used in weather observatory balloons. So this is about the classification of elements into four categories: metals, non-metals, metalloids, and noble gases. Now, next we can see the second category of pure substances, that is compounds, in the next session. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates and recorded videos. Thank you.